almost 20 at on average 39.5 astronomical units or 6 billion kilometers away. Pluto is one of the first significant objects beyond the orbit of Neptune. Its orbit is 248 Earth years long, and its days are equivalent to 6.39 Earth days. It is significantly smaller than Earth, being able to fit inside it almost 29 times. Being so far from the Sun, Pluto is also very cold. Its average temperature is 44 degrees Kelvin, and we know all of this from the New Horizons spacecraft missions to Pluto and beyond. But why? Why send hundreds of millions of dollars worth of advanced scientific equipment to the distant reaches of our solar system? What makes this small lump of space rock so interesting?
Pluto was first discovered in 1930, but its origins reach back further in time. To understand, we have to go back even before we had discovered Neptune. In the 1840s, a man named Urbain Le Verrier hypothesized Neptune's existence by analyzing anomalies in the orbit of Uranus. Something beyond Uranus must be affecting Uranus's orbit. Observing Neptune's orbit, which contained similar orbital anomalies, led to the suspicion of Pluto's existence. A man by the name of Percival Lowell, founder of the Lowell Observatory in Flagstaff, Arizona, was the first person to try and discover Pluto, calling it Planet X. Lowell died in 1916, and search attempts were halted until 1929, when Clyde Tombaugh was given the task to search for Planet X. Once discovered by Tombaugh, the object had to be given a name. Planet X just wouldn't do. There were several names suggested. One was Minerva. However, this was the name of a pre-existing asteroid. Another suggestion was Cronus, but the person who suggested this name was an astronomer who had been accused of plagiarism and lost credibility. Zeus, Percival, and Constance were all suggested by Lowell's wife, Constance Lowell. None of these names were chosen, however. Then, a suggestion from an 11-year-old schoolgirl from England named Venetia Burney, interested in classical mythology, surfaced. Venetia suggested that the planet be named Pluto, after the Roman god of the underworld. It received unanimous votes, partially because it fits the planet's characteristics, but also because the first two letters were the initials of Percival Lowell, PL. The astronomical symbol for Pluto became a monogram of Lowell's initials, and the astrological symbol became similar to Neptune's trident with a circle instead of the central spike.
According to Lowell, Pluto was the size of 7 Earths. It has been since proven to be 1/459th the size of Earth, which is obviously much smaller than Lowell's prediction. Initially, Pluto was considered to be the 9th planet from the Sun. Then we discovered Ceres, Impalus, and Juno and Vesta. And don't forget Haumea and Makemake, all of which are the same size or slightly smaller than Pluto. So in 2006, the International Astronomical Union, or the IAU, held a meeting to redefine the definition of planet to declassify Pluto as planet.
Pluto has very unique characteristics. Its surface is composed of 98% nitrogen ice with traces of methane and carbon monoxide, and there is a higher concentration of methane ice and carbon monoxide ice on the side of Pluto facing Charon. It has mountains which are made of water ice, similar to Neptune's moon Iapetus. It also has very large differences in brightness and color on the surface. Pluto's colors range from charcoal to pale orange to bright orange to white, but it never gets quite as red as Mars. Pluto also is fairly young, as there is no evidence of craters. It has several unique plateaus and planitia, including the Heart, a very flat glacier on the surface of Pluto that resembles a heart, the Whale, a similar glacier that has a formation similar to the tail of a whale, and the Brass Knuckles, a range of large mountains resembling knuckles. These informally named geological structures are likely caused either by impacts, tectonics, or cryovolcanism. Pluto's interior is just as interesting. Because radioactive decay in Pluto's core would cause the surface to melt, Pluto likely has a rock core with a mantle of water ice. It is possible that internal heating still takes place, creating a subterranean water ocean 100 to 180 kilometers thick at the mantle core boundary. We don't exactly know the chemical makeup of the core, but we know it isn't large parts iron, cobalt, or nickel because Pluto has no magnetic field, as far as we can tell. But it does have an atmosphere, and a thick one at that. The atmosphere is composed of nitrogen, methane, and carbon monoxide in equal parts with the respective ices on the surface. Because methane acts as a greenhouse gas, it allows for the melting and boiling of the surface ices and allows the atmosphere to be on average 10 Kelvin warmer than the surface.
Pluto also hosts several moons, the largest of which is Charon. The other moons are Nix, Styx, Kerberos, and Hydra, all named after the mythological entities tied closely with Pluto in the underworld. Pluto and Charon are sometimes considered to a binary system because of the center of gravity is a point outside of one of the body's physical boundaries. This is called a barycenter. Charon also has a unique geology composed mainly of water ice. Charon is much older than Pluto because there are so many indentations and impact marks on the surface. There is also a very large canyon spanning across the surface of the moon, 4 times the size of the Grand Canyon. The Manjet Chasma, as it's known, was most likely formed by the liquid ocean under the surface of Charon, which froze, expanded, and cracked the surface. A great analogy to this is filling a balloon with air, covering it in paper mache, and then filling it with more air. This will cause the paper mache to crack. We don't know much about the other moons of Pluto, but we do know that they are all almost the same. They are all very reminiscent of asteroids.
Pluto and all its moons were believed to have come from beyond our solar system, in an area known as the Kuiper Belt. We still don't know where the Kuiper Belt came from. Hopefully, when the New Horizons spacecraft completes its missions regarding the Kuiper Belt, we can learn its origins. We do know, however, that the Kuiper Belt remained largely unaffected by the processes of the solar system because of its distance from it. Learning more about the composition of the belt could tell us about the early formation of the solar system. The Kuiper Belt holds gases, dusts, and asteroids, similar to the asteroid belt between Mars and Jupiter, but the Kuiper Belt is much, much larger. However, despite its size, the collective mass of all the objects in the Kuiper Belt total only a fraction of the mass of the Earth. Most of the objects in the Kuiper Belt are composed of ammonia, methane, water, and other volatile substances. 3 dwarf planets reside in the Kuiper Belt, as far as we know: Pluto, Haumea, and Makemake. Many of the Kuiper Belt objects are not dwarf planets or even asteroids, however. Many are comets. Let's take a closer look at comets.